So guys, today we are going to design this 40-meter truss in Autodesk Robot version. The truss spacing is 5 meters and it has a length of 50 meters. It's a cross section. So the cross section is the span. So let's get into it. So we'll start our Autodesk Robot. We'll be using this for our modeling. So when you come here, there's this is the interface. You can, before your design, you can come to tools, job preferences. You will see your code combination. You can choose the one you want to make use of. If you don't see what you have there, you come here, check out these codes, check the one that is being used in your country. Then you move it at the right time. Then for my so I'll leave it at this. Under materials, you choose the material that you want to use. Use the codes that are available. Okay, so when you set whatever you want to set, maybe you want to keep it as default. Keep it as your default settings. So we now come here. Then we now come here. We'll come here now. We'll come here. Then we'll come to our grids. When you come to your grid now, in the X direction, we're having two repetitions of 2020. In the Y direction, going to that direction, we're having 10 repetitions of 5 meters. We can apply and close. Yeah, this is it. So we'll come to under structure here. Top level, our design height is 6 meters. First delete what is there, then 60 meter you add, you apply, and then you close. So now the next thing we are going to do is we come to our geometry and you can click on column. So now under column, let's say I want to use this for my column. Then the height 6 meter. Good. Can press that. Maybe I'm putting my columns, also putting support for me. Let's rotate this. Sorry for that. Good. So what we have there, you can now close it. So when you close it now, we can put our trusses. We want to put our truss, come to geometry, structure, insert from library, then here click on this. Then when you double click, close, then the length, that is the span, we are going with 40 meters. The height, that is the thickness, the height is 1 meter. That is 1 meter of the truss thickness, but we're going to slope it. We'll reach there, then feet, we'll break it into 40. At moment release, yes. Continuous calls, you can say no. Depends on you. Can come to more. Go here, good. Our truss height, there's a note here. VS code. Trusses that are 15 to 30 meter, they've given the span to depth ratio 7 to 8, and then from 15 to 30, then from 50 and above they use 25, but since we're still not up to 50, we'll go with 7 to 8. Yeah, so let's say we'll do 40 divided by 8, have 5. 40 divided by 8 will have 5. Okay, so now, but our truss here is already put 1, so remaining 4. So now we'll say D1 4 4. Let's apply and see. Okay, you can see that sections. Let's put the sections that we want. Upper chords. I'm going to be going with angles. Upper chords, angles. Let's give it 100. Okay. Lower chords, equal angles. Let's give it 100 by 8. Okay. Our diagonals is going to be equal angles. Give it 70 by 8. Then the post is the same thing as the most for most part they use it as top chords, those chords there. So the post TUK, equal angles, we use that. Insertion point, our height X, Y, Z. The Z is the height. So now here we'll put our 6 meters. Let's apply this, you can see, and we can close. Good. So as we close this, we have this. So let's select all this. We'll give it 75 angles. We want it to be uniform. So when you come to this material, click choose 275, and then the section, yeah, that's it. I check for the section. I'm going with 75. Okay, so now I'll select the whole of this, but I'll control and select those nodes, the lower nodes. There's a reason why I'm doing that. I want to generate it plus the polyline at the same time. Okay, this is what we have here. Alright, so the next thing we can do is come to our edit. Under edit, we still go to edit, copy, move, activate drag. As we are moving it here, you can now move it in the number of repetitions. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I've already moved one, so yeah, they moved 9 times. If you don't like that, you now move once. Okay, can close this. See that our down is open, But if we didn't remove those unselected nodes, our lower course could have also have these polines. So you see that there's no need for us to model polines differently. It just comes with it. Okay, that's that for that. So the next thing we're going to do is we'll give this poline a different section. So you select. Before we proceed, let's save our work. So I can save that. Okay, let's go. So let's select these things and change. But as I want to select it, I can't select it. Story 6. It means this is above our story height. So since this can't select, let's come to story. Okay. Let's put another height. The height of our truss. This truss was 5 meter. Another height 5 plus 11 and add story 2, apply and close. So I think now we can be able to select this truss. When we select this, right click, create similar, create, select by cross section. It seems our columns are carrying the same properties with the for lines control, and we unselect that. So now we have this. So we'll come here. So as we are here, I want us to use Z polines, but we don't have Z polines. So we're going to sketch our Z polines and insert. You come to your AutoCAD. Depends on the shape. Personally, I'm using BS code, so I can pick one from here and make use of. Let's say I want to use 150. We have 150. Let's see. 150 by 50 by 20 by 2. So I've sketched that. The fold is 20. This is 50. Down is 150. Let's do this again. Let's pick. The fold is 20. The folding is 20. Then 50. 150. The side is 50. I'll go up by 20. Good, that's what we have. I'll pick fillet for a radius of 2. Okay, let's find the origin of this. Come to line 0, select, move this there and delete this. Select this, type W, just we can save it millimeters. Can give it a section of 150 by 50 by 20 by 2. We'll save. Come back to our Autodesk Robot. Come to Tools, Section Definition, Thin Section. We're working with Thin Section. Import DXF. Sections. Doing 150. I'll make sure it's there. Okay, you have it here. So you can select everything here. Right click, properties. It's 275 thickness. You apply. Okay. You can save this. Save to database. As I can say, code Z 150 by 50 by 20. User, you want to use have this. Okay, has been. We need to save it. Come back to your geometry. Save this. So in your geometry now, let's add member, new, user, CZ. So the CZ, pick it 150, add and close. So we can now, it's been selected already, and now apply and close. See that our polyline has been changed. We now have Z polylines. Exactly. So now the next thing we are going to do is we can brace our structure. Trusses needs lots of braces. So that is the next thing that we're going to do now. So come to members. You can say simple member. You can keep it under that. Choose an equal angle of, this is 70. this. Good. We can brace it. So this is 20 meters. To have half to the end. Half to the end. Half to the end. There's another one here. Can now pick one. By cross section. So I'll come to geometry, edit, copy. I think this is okay. Okay. So now the other thing that we can do, we can select this panel cross section. See analyze here so that you ignore it. It means that when we load our claddings, is not going to transfer the loads to these braces. So the next thing we can do is we can add claddings to this structure. We'll select our polylines, select the polylines and come to edit, design, releases, Geometry releases. It's nice. Fix pin. Pin. Send this to pin. Good. Grab that. The next thing we can do is we can add our claddings to our structure. We'll come to geometry and claddings. Rectangle. One way we'll add the load, maybe one way X. So the first direction you usually pick is your X. So we'll tell it that okay, this is X. Start here. Good. You have that. So here we want, since I want my load to lie on polyline, load to be distributed to the polyline, I'll pick here. I'll go this direction as my X. You can press shift the middle scroll of your mouse and rotate while you are seeing your command. I'll click there. I'll click my X. Let's check. Is it the middle? Yeah. Then I'll bring it to Y. Correct. File that. Something I'll do this side. That's my X. I'll come to Y. Let's see. This was not perfectly done. Ctrl Z. And do it. X. And Y. Good. That looks okay. Pick this. Go to the X. And move to the Y. Okay. I'll close this. So for us to this side, let's complete this side. Can use try. Here we use contour. Start here. Come here. like this. Okay. So in our last lecture we did the modeling for this 40-meter span. So in this very one we are going to run or to do our loadings and run the analysis. So the first thing we are going to do here, but let's select this member. The first thing we're going to do here is right click on our screen, come to display, let's check our panels, FE panels, load distribution, let's check. Good, so that we can see the load distribution patterns here. This is going to be distributed to this two. This one is wrong. It's supposed to be, we can change it to Y. Good, you see that it's going to be distributed to our polylines directly. Let's select these two, change it to Y. This is okay. It's fine. And this is fine. So first thing, we generate our wind loads. Come to loads, wind loads, simulation, we generate. Okay, they say positive X, generating positive X and positive Y. It's a symmetrical building. They say we're using 30 meters per second. We'll select this panel, material, copy, and we paste the elements here. Wind speed, so from here we can start our analysis. We'll watch it. Alright, we have this. It has generated these loads for us. It's okay. You can see it goes in this direction. I generated two loads for us, so we can close this now. So we can close here. Good. So the next thing we're going to do is we'll define our loads onto load types. We'll have those one. We're going to have dead load. Yeah, we'll have our dead load. We'll have sub weight. We'll have live load. Then we can close. So we now come to our load types. We will come to load definition. Under node here, let's make sure we are at self weight. Click on self weight. Click here. Good. To apply. Let's come to our dead load. Onto surface area here. Our dead load depends on your calculation. Here I'm going to use 0.25 as my dead load. And pick this or you can select them and put the same thing. And I'll move to my live load. So now let me do a different pattern now. I'll first select these two. Come here on the live load. Use 0.5 for the live load. Add, apply, close. We still have the same thing. Let's see. Load. Dead load 0.5. So now I think we can be able to save our design. If you like, you save it. I call this one analysis. If you like, you save it before you save a copy before you analyze. It's no room. And now click on your calculation. Okay. Yeah, there's some instability detected. Trusses tend to have instabilities in many of these directions, and that's why bracing it is very, very, very important. is the last structure, so give it time to analyze. Okay, we have some warnings, but no error. So now but let's there's something we forgot. Let's do our load combination. Close manual. We use manual load combination. Combination one. Ultimate limit state. Okay. Yes, sure. So can select this, and this we can move this side and apply. Close. Let's do that for now. Let's come to geometry. Under structure type, let's change to 3D truss model and try to run the analysis again and see what comes out of it. Okay. Okay. Let's see our result. Diagram for members. Yes. For our reactions, combination one, we have loads, self weight. Alright. How about this? Yeah, we can turn off panels. So from here, there are other things that you can check. So let's come to steel design, aluminum and steel. So for us, this is the BS code. Let's come to here, tools, job preferences. Okay, so so now we'll group. We're going to group these members for this. You can group these members and then do your design. But first thing, let's check. Let's come back and check. Like cross section. Let's see, 275. Alright, that was good. Want to make sure that everything is fine before progress. Cross section. See, this material is not 275. No problem, we'll reanalyze. So the things you have to check. See, this is also not 275. Let's check this. This is 275. Alright. Okay, this is good. So let's come structure type. Try 3D frame. Analysis. Analyze. Okay. So now we can close this. Let's okay. So apply, close. So let's go for our design. Still design. So as we are here, but let's check our member. Let's turn off this. Good. Turn on this. Okay. So now let's group our trusses. We are to group the top and bottom curves. Select cross section. These are the top and bottom curves. Come to group, new group number 1, member list. Control V, name. You can see CMB, and save this. But before we save, let's come to section. Say we want to use angles, equal angles. We want to use it for the design. If there's other things again that you still want to use, there are other sections that you still want to make use of. This is the right time that you want to add. Go, let's say here under here, this CEAB. The CEAB are double angles, so maybe you also want to choose from double angles too. There's a chance you add, then you still choose our design for top. Select by cross section, copy, group, create new group, add, call it struct, and save. Okay, so that's that. So now we can let's design this too. Remove this, come to code group design. Where is the code? Where is the group? I've created 2 groups. Okay, then we'll calculate. I'll let our software design it for us, help us choose the numbers. It's a light structure, so we'll give it time. Okay, this is what we have here. So we design at double angle of 200 by 16. We are considering the span. The span is 40 meters. Then the struct design with this. So I can select this. Let me enlarge this. So I can select this, select this, then I'll change all. I see that has been changed. It's double one of 200 by 200. So you can now do this for other members that you also want to design. So with this and our factor of safety, I believe our structure is going to stand. You can also do the same for your polines and the rest. If you want to further optimize this truss, go to geometry and let's use 3D truss. You make sure you're in 3D truss design and you run your analysis. Okay, so now let's group let's group these columns too, and we try to design it and see. We call this group 3 with the members, call it columns. The column section, delete all. We are going for universal beams. Okay, to save. So let's go to code group design or the 3. Okay, then we'll calculate. Okay. As our columns are designed by 203 by 203 with combination 6, 150 by 50. Okay, so you can see that in using 3D truss, the members are more effective because it's designing it as a truss, and transferring the load as a truss axially, things like that. So I believe this one is a more economical way of designing these trusses. So you can see that our equal angle, we are low as 100. That is our double angles, so low as 100. Let's enlarge it. So we can you want to go for single angles, you go with this. But I'll go for double angles for the top and bottom. Then for this 60 and for our columns 203 and close and save this. For your braces, if you like to, you can design, or you can use your structural engineering sense. But okay, this might work for braces, stuff like that. If you find the video useful, remember to share and also subscribe.
In the description to this video is a link to our WhatsApp group, so if you're interested to join us on WhatsApp, you can also join us. Thank you, and remember to subscribe to my channel, and there is more to come.